All right. So my name is Fatma Karakuzu. You can call me either Karakuzu or K if it is a long last name for you. All right, whichever is easy. So I've been in education field for about 15, not even 15, maybe 17, more than 17 years. And I really enjoy working with students and doing math with them. And this class for Math 101, I will be your online teacher. So this is the curriculum structure, guys, if you can see. So this is the class you're taking now, the Contest Math 101 class. All right, this is a 1 year long class. So it will be 2 semesters. If you would like to know more about this class, if you need more details, when you go to the website, just under 2022 fall, if you click on online and find the Contest Math, you will see more details about the class. So when you go there, this is the 2 links that you can click to find the information about our class, all right? So the sessions are on Sundays from 5 to 7, and also Wednesdays 6 to 8. So you choose one of them, okay? So if you choose the Sundays, we're starting on September 11th. If you choose the Wednesdays, then we're starting on September 14th. So Momentum is using Canvas platform to share the class information with the students. So it will be sent you an invite to the students' email address, not the parents, okay? So the students will receive an invite from Canvas platform, and under that, when you go to modules, you can find all the necessary class information. So you can see the weekly exercises we are doing. You can find the class recordings. You can find the homework. So all you need for the class is under this platform. So you're going to have homework, and you need to submit them on time, and it will be automatically graded by Canvas. The Zoom link also is in this platform on the homepage. All right, any questions so far? All right. You will also have weekly TA sessions. It's on Friday. During this TA session, you can ask your questions about the homework or the exercise questions that we go over during the class time, okay? So your TA will answer your questions. Also, you can reach the class recordings and all the other materials even after like 6 more weeks when all the classes are over, all right? So for this 2 semesters long, like 1 year long course, if you enjoy like solving challenging mathematical problems, this is the course for you. This is not a boot camp, by the way. This is not preparing you for a particular competition, but this course is helping you to get ready for these. Like you will perform really well if you take these courses, but it's not preparing you for a particular competition. So we will have, like, I will see you 2 hours weekly, okay? So we will have 2-hour lectures, and then you will receive a homework about that week's topics. Then you will have a TA session, which is optional, all right? You can join those TA sessions if you have questions about your homework or questions about the class material that we cover. All right. So this is intended for 5th and 6th graders. However, if your grade level is below 5 and 6, then you can take a qualifying test to be available to register for this class. All right. So here are the topics we will cover for this semester. So we have multiplication, division, fractions, decimals, and number theory. And for each topic we're covering, we have a lot of word problems we will be working on. And these are the topics for the next semester, spring semester. Okay. Questions so far? All right. So if you happen to have any questions later on, you can call the office or you can send an email. I think sending an email will be a better option for you to get answers quickly. All right. So that's it about the class. Now I will have a simple lesson for you guys. If you are ready. Okay, can you please introduce yourself quickly, like your name and your grade level? So I may call you for some of the questions, okay, when we start working on them. So it is better for you to have a paper, pencil, or anything else that you can work on these questions, because I'm not sure if you have a copy of this this handout with you. If you do not have it, it's okay, because this is just an opening lesson, just a simple lesson. All right. So it's okay just to have a paper, pencil, or anything else to work with. All right. Just a couple questions that we will go over. And I may also call you guys to answer some of these questions. So is there anyone who wants to start with introducing themselves? Any volunteering? Alex, maybe we can start with you. Just your name and your grade level, okay?
I'm Alex. I'm in 3rd grade.
3rd grade. Nice to meet you, Alex. Who's next? Come on, you can unmute yourself, just your name and your grade level. You can do it. Anyone? Come on, you can do it. Just unmute yourself. Hi.
I'm Nathan. I'm in 4th grade.
You're what grade, Nathan?
4th grade.
4th grade. Nice to meet you, Nathan. So Nathan is a 4th grader. Alex is a 3rd grader. Anyone else? Who's next? Come on. Yes.
I'm Aiden and I'm in 4th grade.
Hi, Aiden. You're a 4th grader too. And we have one more friend. Can you unmute yourself?
I'm Clement and I'm in 6th.
Clement, what grade you are?
6th.
6th grade. Thank you, Clement. Welcome. All right. So let's see. You can see the problem on the screen, right? Just want to make sure everyone can see it. Just thumbs up if you can. So I know that. Very good. Thank you, Alex. All right, so usually we are going to start with a warm-up question to our lessons, okay? After the warm-up questions, we are going to have a lot of other exercising questions after a brief summary of the topic, all right? So let's see what this question is asking. Use the clues to figure out the 4-digit mystery number. So we have a mystery number. This number is between 8,000 and 10,000. This is our first clue. All right. So you can start working on this. Let's try to find what that number is. This is a number between 8,000 and 10,000. And you can see the other clues on the screen. So if you don't want to talk, guys, it's okay. You can send your answers through chat box. That's fine. All right. So if you have the answer already, you can. Thank you, Clement. You can just unmute yourself, share with me, or you can just send it through chat box. Okay, so the last number is your final decision, Clement? Okay. So we have one answer already. Anyone else have an answer? So this is between 8,000 and 10,000. Few more seconds, then we're going to start working on this. Okay, so anyone else has an answer? If not, then I will start working on this question. You can always unmute yourself to help me, all right? So this number is between 8,000 and 10,000. That means it can be like 8,000 something, right? 9,000 something. Or can it be 10,000 something? Can it be? No, because it is less than 10,000, right? So we're just going to look at these two options. So Nathan also has an answer. Thank you, Nathan. Let's see if anyone else. Aiden also sent me an answer. Thank you, Aiden. And Alex. We'll see now if you are right. Okay, Clement? We'll see now. All right, the next clue is the hundredths digit is one less than the thousandths digit. So if the number is starting with 8,000, then the hundredths digit will be one less than the thousandths digit. So this would be 7. If it is 9,000 something, then the next digit would be 8, right? Okay, the next clue is the ones digit is twice the tenths digit. The ones digit is twice the tenths digit. So if the tenths digit is A, we can use variables, right? You know what variable is. I'm sure that you know it. So if you use a variable for the tenths digit, the ones digit is twice as much as it. So it can be represented by 2A, all right? And the sum of the digits is 23. So the final clue is the sum of the digits is 23. So if you add them all, this should be 23. So let's try this one quickly. 8 plus 7 is 15. If you subtract 15 from 23, what do you get? So I'm solving this equation. So 23 minus 15 is 8, right? But 8 is not divisible by 3. So it's not going to give us an integer value of 8. So probably it's not our answer. Let's try the next one. So if this is A, this is 2A. The sum of the digits is 23. 9 plus 8 makes 17. 17 plus 3A is equal to 23. If 3A is equal to 23 minus 17 is 6. So A is 2. Let's replace that. So 9,824. I think your first answer was correct, Clement, right? Did everybody understand how we work on this kind of questions? Thumbs up, down? Anyone? Please let me know if you're okay. Very good, thank you. All right, since it was our first lesson, I'm going a little slower, but let me know if you want to go faster, okay? You can adjust the pacing. All right, fractions. So a fraction is a part of a whole thing or a part of a group of things, right? And you know what the fraction bar, you know what the numerator is. So for example, 5/8, 5 is your numerator, 8 is your denominator, and this bar is called the fraction bar, all right? So we will have simple fractions that we also call them proper fractions. That means if your numerator is less than the denominator, this is called proper fraction, all right? So for example, 5/6, 5/8, 9/11, 6/16. So these are all proper fractions because the numerator is less than the denominator. All these proper fractions are less than 1, okay? We also have improper fractions. The improper fractions, let me put my chart quickly before it dies. Sorry, guys. Let me put that quickly here. All right, so for the improper fractions, if, come on, don't die. Just a second, guys. All right, good. So the improper fractions are the fractions which the denominator is greater than, less than the numerator, or if they are equal. So 7/7 is an improper fraction, or 13/5 is an also improper fraction, okay? The mixed numbers has a whole number part and the proper fraction part. For example, 2 and 1/5. 2 and 1/5. This is called a mixed number. So now quickly, I want you to determine what type of fractions are those, okay? So Alex, tell me for the first one, 3/10. What kind of fraction is that?
Proper fraction.
Proper fraction, thank you. Clement, the next one, 7/7. Unmute, please. Can you unmute yourself? It's not working? You don't want to? It's okay. You can send it through chat box. 7/7, is it mixed number, proper or improper fraction? Yes, yes, Clement, yeah. You can either unmute yourself or just send it through chat box.
I think it's a proper fraction.
Proper?
Yeah,
Okay.
I mean, it's one whole, so. Like,
yes, it is a whole number. That's right. It's one whole, right? And the one whole means also an improper fraction. Okay. So this is an improper fraction. And the next one, Nathan, 9/8.
improper.
It's an improper fraction. Very good. And the next one, Aiden.
Proper.
1 and 1/2. We have proper, improper, and we have mixed number.
Mixed number.
It's a mixed number because it has a whole part, right? And the fractional part, so it is a mixed number. Very good. And the last one, 101/100. It is very similar to the D, if you can notice. So it is also a mixed number. Very good. You can change an improper fraction into a mixed number. You can change a mixed number into an improper fraction. So we're going to see how that works. So for example, 11/4. This is an improper fraction, and you can change it into a mixed number. You can write it as a mixed number. So how we do it is simple. You just divide. So 11 divided by 4. Okay, 11 divided by 4. So how many 4 goes into 11? So just simple division. So 2 times 11 minus 8 is 3. So that means you have 2 wholes, okay? You don't change your denominator, it's still 4. And the remainder is your numerator. So your remainder is the numerator. So it is same with 2 and 3/4. So this improper fraction 11/4 is same thing with 2 and 3/4. Okay. Would you like to practice this with B? So please work on this and send me your answer through chat. If you can't write it in the chat, you can just unmute yourself and share with me. 29/2, and I want you to write it as a mixed number. So you don't change your denominator. The remainder is your numerator, okay? And the answer to your division problem is your whole number part. So you try it. Okay, anyone is ready with an answer? Aiden says it's 14 2/3. Clement says it's 14 1/2. Okay, let's do this division and see which one is correct. Okay, so I'm going to divide 29 by 2. So 2 goes into 2 1 times, right? And then into 9, it is 4 times. And the remainder is 1. So your answer is 14. That means you have 14 2's goes into 29. So 14 whole parts. And then 1 out of 2. 1 is your remainder. Okay? So that's how you change a mixed number, improper fraction into a mixed number. Let's see what we notice here. Let's check these two mixed numbers. So here, if you multiply 2 times 4, that's an 8. And if you add the remainder, 8 plus 3 is an 11. So that gives you the numerator. Okay? So let's try it with this second mixed number. Multiply the denominator with your whole part, which is 14 times 2, 28. And if you add your remainder, which is the top number, that's 29. So this is how you get your improper fraction if you're given a mixed number. So this is what we're going to try on the next page. So you can change a mixed number into an improper fraction. All right. So why do we need to do this? Like, why do we need to change them into different forms? So you may be given some problems that you need to add or subtract improper fractions, mixed numbers, like proper fractions with improper fractions. So you need to be able to change them, like convert them one another, so you can easily add or subtract them. Okay. So I'm going to just try one of them and then go to the next page. So I want to cover a few things before our time's up. Okay. So let's see the second one. 6 and 2/7. 6 and 2/7. So remember what we do. 6 and 2/7. So we just multiply, because this is the opposite of division, right? When we divide, we divide the number with the denominator. So when we get that, that's the whole part of our mixed number. So now we're going to multiply these two numbers to get our whole part. So 6 times 7. What is 6 times 7? Yes, Alex?
It's 42.
It's 42. So you multiply 6 and 7, which is 42. But we have a remainder, right? When we do that division, remember the remainder goes to the top part of the denominator. So we need to add that to our product so we can get the top part of the fraction. Do we need to change the denominator? No, it's the same. So it's 44 over 7. 44 over 7 is the same thing with 6 and 2 sevenths. You can try it. You can divide 44 by 7. You will get the same answer. So 2 goes into your numerator. 6 is your whole part. And 7 is the denominator. Okay. All right, let's see what else we have about fractions, equivalent fractions. Now look at these pictures. You have 4 circles. So can Nathan tell me what the first fraction represent, what the first circle represent? How would you write it as a fraction, Nathan? Can you tell us? Nathan, you hear me? Yeah, for the first circle. What fraction this circle represent?
Half. One half.
Very good. So I'm going to put half just under this. So this is 1 over 2, right? So Clement, what about the second one? So look at the shaded parts. How many shaded parts we have?
That's 1/2.
That's right, but I need you to write it
2/4.
as the original fraction that picture
2/4.
represents. 2/4. Very good. Very good. So this is 2 shaded parts out of 4 equal parts. So it is 2 out of 4. Aiden, what about C? How many shaded parts we have?
3, 6.
Very good. And the last one, Alex?
4 out of 8.
4 out of 8. So what do you notice, guys? 4 out of 8, 3 over 6, 2 over 4, 1 over 2. What do you notice? What can you tell about all these fractions that we put here? Aiden, what do you think? 1/2, 2/4, 3/6, 4/8.
The number on the bottom is 2 times more than the number on the top.
2 times, you said?
Yeah.
Okay, so is always the top number is half of the bottom, or the bottom number is 2 times the top number. Very good. So that means they all represent half of a whole, right? See, this piece is half of the circle. This is also half of the circle. So these are all representing actually one fraction, which is 1 out of 2. So that means you can write a fraction in different forms. You can multiply the numerator and denominator with the same number to get equivalent fractions, or you can divide bottom and top number with the same factor to get the equivalent fractions. All right. So for example, these two, are these equivalent fractions? So there are different ways to check this. One is that you can try to get the common denominator. For example, 7 times 4 makes 28. So I can multiply the top number by also 4 and see if they are equal. So 2 times 4 is 8. 7 times 4 is 28. So that gives you 8 out of 28, which is same with the second one. That means these two are equivalent fractions. Okay. We have one more friend. Hello. Can you introduce yourself quickly, please? You can unmute yourself.
I'm Charisse.
Hi, Charisse. What grade are you?
4th.
4th grade. Welcome, Charisse. So the next one, the next method is that you can use cross products. So the cross products will also help you to understand if they're equivalent. So cross products means I multiply 4 and 30. 4 times 30 is 120. And I multiply 12 by 12, which is 144. If these two numbers are same, these are equivalent fractions. In this case, they are not same, so these are not equivalent fractions. Okay, so this is how you determine if they are equivalent or not. You can enlarge a fraction, as we just practiced a little bit. So if you multiply the top and bottom number with the same number, you can get an equivalent fraction. You can enlarge it. Okay, so 1/5. You multiply the top number and bottom number with the same number you choose. Okay, so I choose 2. So if I multiply these two by 2, I get an equivalent fraction, which is 2 out of 10. 2 out of 10 is same thing, but 1/5. They represent the same piece in a whole. Or 11 out of 4. You can multiply this by 5, this by 5, or any other number, and you will enlarge this, you will get an equivalent fraction. Okay. You can also simplify fractions. Now we enlarge them by multiplying. So what do you think how we can lower them, how we can simplify them? It's okay, guys, you can unmute yourself and just share your ideas. I will be happy to hear you guys. So we use multiplication to enlarge fractions. I can, yeah, I can understand what you say, Nathan, but I can hear you. But I can read your lips. Divide, you said divide, right? Yeah, so you use division to simplify them. So for example, 12 out of 18. So how I can simplify this fraction? I need to find a number that can divide both 12 and 18 at the same time. So I need to find a common divisor. So for this case, 12 and 18, I see that these two can be divisible by 2. I can do that, right? I can divide both numbers by 2. It can be a different number, but the first number came to my mind was 2. So I divided by 2, which is 6 out of 9. Do you think this is the simplest form? Do you think I can go ahead and divide it more? Right? Aiden says, no, this is not the simplest form. So I need to find another number that can divide both 6 and 9. And I see that 3 is a common divisor for these two. So let's divide them. 6 divided by 3 is 2. 9 divided by 3 is 3. So 2/3. Do you think this is the simplest form now? Yes, very good. Because I cannot divide them anymore, right? So this is the simplest form. Very good. So you can do the same with all of these others. I'm going to pick just one more and then go to the next page. So for example, 700 over 210. Can someone tell me a common divisor for these two numbers? Any number you can think of that. 70. Okay, thank you, Aiden. So you can divide both numbers by 70. So 700 divided by 70 is 10, right? What about 210 divided by 70? What is it? Yes, Alex?
It's 3.
Is 3. Is this the simplest form? Can you divide it further? No, no more. So this is the simplest form. So what kind of fraction is this? Is this a proper fraction, improper fraction, or a mixed number? What kind of number is this? Fraction is this?
Improper.
Thank you, Alex. This is an improper fraction. Very good. But you can change it into a mixed number if you need to, if the question is asking you to do it. So I'm going to do it just to practice, okay? So remember that we multiply these two to get the number at the top. So this is what I'm going to do. So 3 goes into 10 3 times, right? 3 times 3 is 9, and 1 more makes 10. So 3 and 1/3 is the mixed number. Very nice, guys. All right. Since you can convert the fractions like improper to mixed number or mixed to improper, or like you can change one to another, now you can also get like common denominators by using equivalent fractions. That means you can compare and order the fractions. Okay, let's practice this a little bit. So if you have the same denominator, it's easy to compare and order the fractions. The smaller the numerator, smaller the fraction. Okay, so 9/7 and 6/7, the denominators are same. 9 is larger, so 9/7 is greater than 6/7. What if you have the numerators equal? So for example, 11/3, 11/5. So if the numerators are same, then you look at the denominators. The fraction with the smaller denominator is the greater fraction. So 11/3 is greater than 11/5. If you have different numerators, different denominators, then you can use the butterfly method, or you can use the cross product. So the people are using different terms for this. So you can use the cross product to compare and see which one is greater. We're going to practice this here. So I'm going to pick just 2 questions, one from top rectangle and one from the bottom box. Okay, so let's see. Let's pick B. So let's see. 4 out of 15, 7 out of 45. Are the numerators same? No. The denominators are same? No. Then what I can do is either make them equivalent. Okay. Either make the numerators equal to each other or denominators equal to each other, then compare. Or I can use cross product method. All right. So I'm going to use cross product method for this question. So 4 times 45. Can someone do the math and tell me what is 4 times 45 equals?
9.
4 times 45.
180.
180. So this is 180. And 7 times 15.
75.
Say it again.
105.
75.
105. Okay, let me use different colors just a second. Okay, so here. So I start with 4 times 45. So I'm going to put that fraction at the top here. I mean, product at the top here. It was 180, right? And then 15 times 7, 7 times 15, which was 105. Now I can compare these two top numbers, 180 and 105. Aidan, what do you think? 180 is?
180 is bigger than 105.
Then 4 out of 15 is greater than 7 out of 45. Does that make sense? So this is greater. This is the cross product method. All right. So 4 out of 15 is greater than 7 out of 45 because the products, the cross products tells us that. So let's try the second method, like getting the equivalent numerators or denominators with another question here, A, B, or C. I'm going to pick one of them. So let's go with A. So 3 out of 5, 5 out of 7, 9 out of 11. None of the numerators or denominators are same, so it's not going to be easy to compare unless you have the same numerators and denominators. So this is what I'm going to do. Can we get the same numerators just to make it a different type of working? Because we usually get the denominators same. So I'm going to go with numerators, 3, 5, and 9. So I think 45 can be the number. We can get them equivalent to each other. So I'm going to multiply this one by 5. Let's get a different color, 5. This one by 9, and this one by 15. Now I have all the numerators equal because 3 times 15 is 45. And of course, I multiply the bottom number with the same thing, 5 times 15. What is 5 times 15?
75.
Thank you, Aiden. And then I have 5 times 9, again, 45. And 7 times 9. What is 7 times 9?
63.
Thank you. Very good. And the last one, 9 times 5 is 45. And
65.
very good. Thank you. Appreciate it. All right. Now I have all the numerators equal. Remember, the fraction with a larger denominator is the smallest one. The fraction with the smallest denominator is the greater one. So the greater one will be this one, right? So this is number 1, and then this is number 2, and this is number 3. So if you want to put them in order, 45 out of 55 will be the greatest one. The original fraction is 9 out of 11. This is greater than 45 out of 63. The original one is 5 over 7. And the smallest one is the fraction with the largest denominator, which is 3 over 5. So this is how you order fractions with different numerators and denominators. Any questions so far? Perfect. Let's go to the next page. So this picture is really helpful for you guys to understand how you add fractions with common denominators. So for example, if you notice, the first picture is divided into 5 equal pieces and 2 of them are shaded. So that represents 2 out of 5. And the second one is 4 out of 5. So when you add these 2 fractions with the same denominator, you actually just add the shaded parts. So if you want to rearrange them, you can like move these 3 to the first picture to shade all of them. And then remaining part will be 1 out of 5. So that represents 1 whole and 1 out of 5. Or you can just add all the shaded parts, which is 5 here and 1 more here, 6 out of 5 equal pieces in each whole. So 6 out of 5 or 1 1/5 is the answer of this addition problem. So let's practice this. I'm going to go with the word problem this time, okay? Let's go with the word problem. On the morning of April 5th, 1/10 inches of rain fell on Beast Island, 1/10. Later that day, another 7 out of 10 inches of rain fell. So another, that means an addition problem, right? How many inches of rain fell on Beast Island on April 5th? So when you want to find the total, you need to first check if you can easily add them. I think I can because the denominators are same. That will be super simple because the denominators are equal. That means you can just add the top numbers. 1 plus 7 is 8. So do I add the bottom numbers? Is this equal to 8 out of 20? Should I add the bottom numbers, the denominators? 10 plus 10 equals 20. What do you think? Alex says no. Nathan, what do you think? No, of course, because remember from the picture, like model at the top, that denominator represent how many pieces you divide each whole. So you're not going to add the denominators. It is still 10. So it's 8 out of 10. You can simplify if the question is asking you to do so. Okay, you can simplify it. All right. Let's see what else we have. Adding and subtracting rational numbers with different denominators. So that's not hard because we know how to change, we know how to get equivalent fractions. So if the fractions do not have a same denominator, then we can make them same by using multiplication or divisions. Okay, so let's try that. So I want to add these two fractions, 4 out of 5, 1 out of 10. They are not equal, they do not have the same denominator, but I can multiply this one by 2 to make it a 10. That makes this addition problem easier. So let's multiply this fraction by 2. It will give me 8 out of 10 plus 1 out of 10. Now I'm ready to add the top numbers, which is 9 out of 10. This is that simple. Okay, so let's try it with 3 fractions, 3, 4, and 6. Who can tell me a common denominator for these 3 numbers? 3, 4, and 6. A common denominator. A number that can that is divisible by all 3, 4, and 6.
1.
Can you divide 1 by 3?
Yes.
I mean, to get a whole number, to get an integer without any remainder, without any decimal points. So let's try another number. What about 12? Can you divide 12 by 3 without any remainder? Is it divisible by 3? 12 divided by 3. Yes. Okay. What about 4? Can you divide 12 by 4? 12 by 4. Yes. Thank you. And what about 6? 12 by 6 to get a whole number. 12 divided by 6 is?
2.
2. So that is divisible. So 12 can be our common denominator. Okay. So 12 will be our magic number. So how can I change all these denominators into 12? So I will just use multiplication. 3 times what makes 12?
4.
Thank you, Aidan. So 3 times 4. That means I'm going to multiply the first fraction, the top and bottom number, by 4. 4 times what makes 12? 4 times what makes 12? Anyone? 4 times what makes 12?
3.
30? 3. Yes, Alex. So you
3.
yes, thank you. And 6 times 2 is 12, right? So let's convert them quickly. 2 times 4 is 8 out of 12. This is the first one. 1 times 3 is 3 out of 12. And the next one is 5 times 2, 10 out of 12. Now we have all the same denominators. We are ready to add them together. 8 plus 3 plus 10. That means 21, right? Out of 12. So this is our answer. You can change it into a mixed number if you need to. So let's see one more page. Maybe we can answer 1 or 2 more questions, then the class will be over, guys, for tonight. Okay. Is there any question that you want to try? You can pick one. We have about 4 minutes. It can be one of these questions at the top or one of these questions at the bottom, the word problems. Okay, I will pick one. So I'm going to pick a subtraction question, okay? Let's pick a subtraction question. It can be number 3. Let's try number 3. A subtraction question. It's a different one, so let's try it. So when you subtract mixed numbers, you need to first change them into improper fraction, okay? So to change them into improper fraction, you know what to do. 2 times 11 is 22. Add the top number, 26. So this is 26 over 11 minus 3 times 2. Please check my math so I'm not making any mistake. 3 times 2 is 6 plus 1 is, my pen keeps dying. Okay, 6 plus 1 is 7 over 2. Now I can subtract, but there's one more thing I need to do because the denominators are not equal. So I'm going to multiply this one by 2 and this one by 11 to get the same denominator. Okay, this will help me to get the same denominator. So 2 times 26 is 52 over 22 minus 7 times 11 is 77 over 22. Now they are equal. The denominators are equal. That means you can subtract them. So what is 52 minus 77? Anyone knows what that is? If you work with integers, you can do it. If you don't know, it's okay, but I want you guys to try it. Just try it. It's okay if it is not the correct answer. 52 minus 77.
Negative 25.
Is negative 25 because 52 is smaller than 77, right? So it is negative 25 over 22. Thank you, Alex. So this is how you do subtractions with fractions. Okay, so basically that's what we do with fractions. There are more word problem questions, but we don't have much time, guys. So hopefully we can cover more in our lessons when we started on September 11 or 14, depending on which day your session is. Okay, so this is it for today. Do you have any questions before I close the session? Okay, so in our lessons, sometimes what I do is I play Kahoot game to go over the topics that we learned. So just a fun time with the class all together. I don't know if you enjoy playing Kahoot game. We can try different things too to just review what we learned. Okay, maybe every 2 weeks or so. Okay, we will try to do that, maybe 3 weeks. So this is it for today, guys. I hope to see you in 2 weeks in our lessons, either on Wednesdays or Sundays, whichever you assigned. All right. If you do not have any questions, I'm going to stop the recording.